Hello, my name is Ross Sinclair, and I am the president of Creative Energy Solutions, and also the inventor of the Sinclair water and wind power systems. The test we just finished in Vancouver, British Columbia was set up to test the viability and functionality of both the tidal system and the deep ocean current system. Hello from Vancouver. We're here in Bracewell Marine Yard with the Sinclair Water Power Submariner 3, which was manufactured in my yard in Calgary. We've transported it here, and we're just getting ready for the test, tidal simulation test. Now, we also have here a what's called the load bank, and this was manufactured with a panel on here to measure the loads from the two generators. Yeah, on this side we have a flow indicator which will indicate exact flow to a tenth of a knot. We are simulating the currents by towing our devices at varying speeds in the mouth of the Fraser River. Both of these systems were manufactured in my shop on my acreage south of Calgary and then transported to Vancouver for these tests. By closely monitoring the water speed along with the power output, we can establish a benchmark which we can use to size future applications of this technology. This is the tidal device, which was designed to make power with flows in both directions. You will notice that we have made a makeshift bow on the stern of the herring skiff to allow us to tow the unit backwards. In the first part of our test, we are towing our patent-pending triangular-shaped tidal device in both directions. The monitoring of the power output and speed was done by Darren Bohr, the president of Accurate Power Group Limited. He has published the test results, and we are very pleased with them. We found similar outputs of the generators when towing this device in opposite directions. In the second test, the screws were mounted on either side of the herring skiff and lowered so that the screws were at a 30-degree angle down from the horizontal. This is to simulate our patent-pending system for the Gulf Stream and other fast-moving ocean currents. Overall, we were comfortable that the two concepts function as expected, and at 7 knots the generators hit the design level of 5 kilowatts each. At one point we reached 7 kilowatts at about 7.3 knots. The power production goes up based on velocity cubed. In the currents at the fourth site located in the minus channel and the Bay of Fundy, these same screws would produce over 35 kilowatts because of the flow rates. For our next test, we are going to relocate to the Bay of Fundy at the Briar Island test site, which is operated by Fundy Tidal. We'll put a unit in that actually functions right in the tide and will be connected to the grid. This unit will be a minimum of 5 times the size of this one. We really look forward to truly proving that it works exactly the way it's designed to work. I believe the systems you have seen in these two tests are the simplest and most cost-effective as well as most environmentally friendly way of capturing the power in water currents. These systems clearly have the most proven aspects of any out there. When you consider the helical screw has been in use for over 2,000 years and the generators we use are simply off the shelf. The combination of these have been put together in a patentable system which is very simple and functional, that is made up of known and proven components. The power potential in the minus channel in the Bay of Fundy is for 2,500 to 3,000 megawatts. That is huge. The reason that the fourth site was set up there is simply because it's the most challenging spot in the world and certainly the most potential in the world. I simply believe that my technology is a major game changer simply because it will produce power 3 or 4 times more economical than any of the other systems being tested there. And I truly believe that I can prove that to anyone who really takes the time to listen to all the reasoning behind that and why it is provable. Thank you.